How do we calculate acceleration from a velocity time graph? So here is my velocity time graph. We've got, well, we can see that this journey lasts 10 seconds, and we can also see their top speed was 15 meters per second. So we're going to have a look at calculating the acceleration. There's two pieces of information I can get from this graph, but I can also find out acceleration from this graph as well. So we're going to find acceleration for different parts. So we're going to find it for section A, section B, and section C. So we're going to have a look at section A first. So if we write our equation, so acceleration is equal to the change in velocity, so delta V, that means change, divided by the time. Okay, so we need to see how much did our velocity change in that given time for that given section. Okay, and we're just looking at section A at the moment. So change in velocity is calculated by doing the final velocity, so Vf, minus the starting velocity, Vs, and then divide that by the time. Our final velocity for part A, where did we get up to? Our final velocity was 15 meters per second. Okay, our starting velocity for section A was 0, so 15 minus 0, divided by the time it took to complete that whole section, okay, which was 3 seconds. So 15 minus 0 is still 15, and then 15 divided by 3 is 5. Okay, so our acceleration for that section is 5, and that is 5, and the units are meters per second squared. So that means for every second, they're getting 1 meter per second faster. Okay? Sorry, 5 meters per second faster. So the acceleration for that section A is 5 meters per second squared. Okay, section B is nice and easy. We can see this whole line is flat for section B. So they haven't changed their velocity at all. They've not changed speed, so their acceleration, but they can't be accelerating. If you haven't got faster or slower, you can't be accelerating. So the acceleration for B is 0. Nice and easy. Okay, now we're going to have a look at the acceleration for C. Okay, so I'm going to keep that equation there. So acceleration is change in velocity over time. Just get rid of that. Change in velocity divided by time. So again, change in velocity is the final velocity minus the starting velocity, and then divide by time. So section B goes from here to here. So I'm just going to draw down to help me see everything I need to see. Okay, so the final velocity for section C, we finish down here. And if we read across, that's 0. We're back to 0. So the final velocity is 0 minus the starting velocity for section C. Well, we started up there, which was 15. Okay, and then the time taken to get us there. Well, we started section C at 5 seconds, and we finished section C at 10 seconds. So the length of time it took us to do section C is the difference between these two numbers, which is 5. So our acceleration will be 0 minus 15. Okay, 0 minus 15 is minus 15 divided by 5. Minus 15 divided by 5 is minus 3. Add in the units, meters per second squared. Now you might ask why this is a minus number. That's a bit strange maybe. It's a minus number because this object is not accelerating. We can see they're slowing down from 15 to 0. So they're not accelerating, they're decelerating. And a deceleration is the same as a negative acceleration. Okay, so it should be minus numbers if we're headed in the downward direction like we are in part C. So minus 3 meters per second squared. Okay, so you've seen all 3 examples of how to use a velocity time graph to calculate acceleration. So you should be able to try these on your own now.